All right, IBAISL2. We've come to the close of Chapter 8, which is our multivariable statistics target. I guess I should say that this is multivariable stats. So the first thing we learned in this unit is Spearman's rank correlation coefficient. Remember, this is different than Pearson's correlation coefficient. Spearman's usually has to do with nonlinear data. But the major difference is how you compute it. You have to rank the data in order and then put them in for L1 and L2. I've also put in the calculator steps right here that you put stat, test, and then do a linreg t-test, and you're looking for the R value. I think the hardest part of this unit is definitely keeping track of all the different calculator steps that we do, because they're all sort of similar but like slightly different. The biggest thing we did, well, one of the biggest things we did in this unit was chi-squared test for independence. Remember, you're trying to tell if two parameters are independent of each other or not. This is where we first brought in hypothesis testing. A lot of the tests we're going to do in this video, or talk about in this video, are hypothesis tests, where there's a null hypothesis and an alternative hypothesis. But the null and alternative hypotheses are different depending on what type of test you're doing. So a chi-squared, you're telling if the two parameters are independent of each other or not. The null would be that they are independent. The alternative would be that they are dependent. Know how to find degrees of freedom and punch it into your calculator to be able to find the p-value. Remember, the p-value has a lot to do with the significance level. That's what you test it against to see if you're going to accept or reject. The actual chi-squared statistics, I think we call it chi-squared calc, you compare with a critical value. And that is usually from the table, or they give it to you in the problem. The way you find the chi-squared and the p for a chi-squared independence test is you put all your data into a matrix button, and then you stat, test, chi-squared test. Next up, we did the chi-squared goodness of fit test. This also had degrees of freedom, but it was a slightly different formula for degrees of freedom. It was just the number of data types minus 1. This test is for uniform/normal distributions, but because we're going to do normal distributions in Chapter 7, I think we're going on record as saying we won't do the normal one. We will only do a uniform distribution problem. So heads up. The way you find the chi-squared goodness of fit statistics, really you're just looking for the p-value on this one. So I guess I should put that. Yeah, you're going to look for the p-value with this as well. You put all your data into L1 and L2, then you go stats, test, chi-squared goodness of fit test. Remember, this only works on a TI-84. There is a way to do it on a TI-83, but I posted a video about how to do it because it's a little bit complicated. The last thing we did in this unit is we did a t-test. I apologize in my first video that I didn't talk about one-tailed versus two-tailed, so I'm saying it here. A one-tailed test is when you're determining if the means are greater than or less than each other, and a two-tailed is when you're testing if they don't equal each other or not. Yeah, all of those have to do with differences in mean. The way you find it is you put all your data into L1 and L2, then you do stats, tests, and then a 2-samp t-test. Once again, with that one, you're also looking for a p-value. And then measuring it against the significance level, the same way you do it with all p-values. All right, you guys, I believe that's everything we had. Happy studying.